Okay, this question. An experiment was carried out to determine the relative molecular mass, the MR, of a volatile hydrocarbon that was a liquid at room temperature. Okay, so MR, so that's going to be it's going to be mass divided by the number of moles. A known mass of X was vaporised at a known temperature and pressure, and the volume of the gas produced was measured in a gas syringe. So we've got our results table here. I'm going to check before I do any of the calculation that all of these are in the format. Now this is, I hope you appreciate, this is going to be a PV equals nRT calculation. First of all, the mass here, that's going to be 0.194 grams. The temperature is in Kelvin, that's right. So 102 kilopascals is going to be 102 times 10 to the 3. So it's 102,000 pascals because it's got to be in pascals. The volume is in centimetres cubed, so we divide that by 1,000 to get it into decimeters cubed, and then we need to divide it by another 1,000 to get it into meters cubed. So that's dividing by 1,000,000 or times 10 to the minus 6. Appropriate number of significant figures. So this is often forgotten because you're so pleased that you've got the calculation done that you forget this. And we've got 3 significant figures here, 3 and 3 and 2 here, and you can only be as precise as the least. So I'm just going to write myself a little reminder down here that when I've got my calculation done, it needs to be to 2 significant figures. So my PV equals nRT. I've got my mass. I need to find N, the number of moles, in order to get the MR. Okay. So number of moles is going to be PV divided by RT, and that will be one of the marks for rearranging it. The next mark will be for putting your values in that have been converted as they need to be, so that they're in the format that is required. So pressure is 102 times 10 to the 3 times the volume, 72 times 10 to the minus 6, divided by the gas constant, 8.31, multiplied by temperature, which is already in Kelvin, 373. So there'll be 1 mark for the conversions there. Mark 3 will be for the correct answer. So the standard when we're doing our calculations is 3 significant figures. So working that out gives you 0.0237. And then we're asked to calculate the MR. So I've got the number of moles now, and I've got mass in the question. So MR is equal to number of moles, mass divided by the number of moles. So the mass in the question is 0.194 divided by the number of moles, 0.00237. And then on my calculator, I have a look at what's written there. So to 2 significant figures, I'll look at the third significant figure to decide whether I'm going to round it up or round it down, which gives me an answer of 82. So 1, 2, 3, 4, and then 5. Part B, analysis of a different hydrocarbon. So clue is here. So there's only 2 elements, hydrogen and carbon. If I've got 83.7% of carbon, the remainder that makes it up to 100% is going to be hydrogen. So I need to calculate the empirical formula, and then I'm given the MR here in order to calculate the molecular formula. So for the empirical formula, let's start off with carbon and hydrogen. So percentage, 83.7. So the difference here is going to be 16.3. Now, whether you're given us percentages or masses, the calculation is the same, because if you think about it as a percentage, this is the percentage as if the mass was 100 grams. So you'd have 83.7 grams of carbon, 16.3 grams of hydrogen. So what we've got here is the ratio by mass, and we need the ratio by moles. So I need to divide this by 12, divide that by 1, which gives me 6.975 to 16.3. If I now divide through by the smallest, which is my carbon, so divide through by 6.975, divide through by 6.975. You can see this is going to be 1, and as I look at my calculator here, this is going to be 2.3. Now, here's the key bit here. When you've got 0.3s or 0.6s, that's when you've got thirds. So what I need to do here is times all of this through by 3, which gives me a 3 to 7 ratio. So my empirical formula, so I've only got 2 marks so far because I've not actually written the empirical formula. My empirical formula will be C3H7. Now, that has an MR of 43, which is half the MR of the molecule. So that means that I need to double it in order to get C6H14, and that's my molecular formula there. So 1 mark for that, 1 mark for that, 1 mark for getting this ratio correct here, and 1 mark for being able to work out the 16.3 just there.